Hi, in this question, we have been given the static pressure ratio across a stationary normal shock is given by P2 over P1 equal to 1 plus 2 gamma divided by gamma plus 1 into M1 square minus 1, where M1 is the upstream Mach number. For a stationary normal shock in air, gamma value is 1.4 and R is equal to 287 joule per kg Kelvin with upstream flow conditions given by speed 800 meter per second, static temperature 300 Kelvin, and static pressure is of 1 atm. The static pressure downstream of the shock is, so we need to find the static pressure in the downstream conditions. So let's write the given condition first. So here we can draw, suppose this is the normal shock wave, and here we have upstream condition of the flow, and here we will have downstream condition, and the values are given for upstream. So here the speed, that is V1, is 800 meter per second, and the static temperature is given as 300 Kelvin, and the constant values like gamma is 1.4 and gas constant value is 287 joule per kg Kelvin. And here this upstream condition will have Mach number M1, and similarly in the downstream conditions these values will be changed, that is Mach number will be M2, similarly pressure will be P2, here pressure is P1. So we need to find the static pressure P2 here, and the relation between P2 and P1 is already given in this question. So for the solution part, first of all we need to find the upstream Mach number. So this Mach number M1 is given as the upstream velocity divided by the speed of sound in the upstream condition. So we can find this A1, and this is given by square root of gamma R times T1, where T1 is the upstream static temperature. Let's put all this value here, and we will find A1 is equal to square root of 1.4 multiplied by 287 multiplied by temperature is 300, and this will be in meter per second. So if we solve this, we will get A1 equal to 347.17 meter per second. So now we have calculated A1 value, and we need to find the Mach number. So this Mach number M1 will be equal to, V1 is already given, that is 800, and A1 we have calculated 347.17. So on solving this, we will get M1 is equal to 2.3. So we have calculated Mach number, and now we need to find the pressure P2. So here we have relation between pressure P1 and P2, and this is given by 1 plus 2 gamma divided by gamma plus 1 multiplied by M1 square minus 1. So let's put all this value here, and we will get 1 plus 2 times of 1.4 divided by 1.4 plus 1, and then 2.3 whole square minus 1. So let's solve this, and we will get this as 1 plus, now solving this term, we will get this value as 5.03. So we can write this as 6.03, and this is basically a pressure ratio across the normal shock wave. So we need to find P2. So P2 will be equal to 6.03 multiplied by P1, and P1 is given as 1 atmospheric pressure. So this P2 will be also 6.03 multiplied by 1, which is 6.03 atmospheric pressure. So finally, we can say that the static pressure of the downstream condition is 6.03 atm, and this is the final answer of the given question. I hope you understood the solution. Thank you.